Tousimis Research Corporation's supercritical AutoMegaSamdri 915B, the dryer system for samples using liquid carbon dioxide. So this system includes the condenser, the solder condenser, and the operation is pretty simple from this control panel here, and this is the process chamber. So I'm just simulating a sample holder here. So I have a silicon sample here, and I'm going to fill it up with isopropyl alcohol. So various sample holders of various capacities and sizes are available from the manufacturer, and also the sample holders. The sample holder helps for the sample to stay stable while the process operation is in progress. So first, place the sample, fill it with alcohol. Isopropyl alcohol is always recommended. The user's manual will be included with this machine with a detailed procedure of operation. So once the sample is placed and all the thumb screws are finger tight, I'll use a spanner wrench to tighten them. So this is a 34 to 36 millimeter spanner wrench. And what we do is first make sure that the system after power up is in vent, and also the solder condenser is on. The condenser should be on 5 minutes before this system is on. After powering on, the system should be left on for at least 5 to 10 minutes to warm up. So gently tighten first the opposite nuts so that the gasket is tightened evenly. So this system uses two gaskets, a nylon backup gasket, they call it backup ring, and a Teflon gasket. So once we initialize the process, these front panel switches should be turned on. I'm going to show it in a minute. There are also needle valves in line with the cool, fill, purge and bleed valves inside. So the system is semi-automatic kind of operation here. Once you cool and fill, the system will finish the rest of the cycle automatically. So there is a purge timer here. The purge timer is to be set depending on the size of the sample holder, and typically you can set between 2 or 3, and each division here counts for about 5 minutes of time. So if I select it at 1, so the purge timer will be on for about 5 minutes, and 2 it will be 10 minutes, and 3 will be 15 minutes, and so on. So I just finished one cycle of operation. So now I'm going to repeat the process again just for demonstration purpose. So all these locking nuts should be tightened up gently. I should not use overpressure. And So I'm going to start the operation by pressing the cool button. So as soon as we press the cool button, the vent light will go away. And then once you start cooling, you have to open the valve on the CO2. And then also open the needle valve slowly. The system is connected to high pressure CO2 using these braided high pressure hoses, and the exhaust connection, which is a 1/8 inch swage lock connection connected to the solder condenser. And these are the cool exhaust, the CO2 cool or bleed CO2 exhaust coming from this line here, going to this T, and as well as the vent outlet from here is connected to a exhaust vent. And there is a drain port, so the valve should be open, and I'm collecting the drained alcohol, if any, which is condensated, will be drained into a vessel. The unit requires 110 volts AC power, and the two outlets are required, one for the condenser and one for the main system. So the application of this AutoMegaSamdri 915B is to eliminate stiction or adhesion between the substrate, usually the silicone-based substrates, and the microstructure occurs during the isotropic wet etching of a layer. So we are taking advantage of the supercritical temperature of carbon dioxide, which sublimates at about 31.4 degrees Celsius. So in this phase diagram where temperature versus pressure, so that this is the critical point temperature where the superfluid sublimation takes place, and the CO2 gases will turn into vapor and vapor to liquid as we go down on temperature. But what we do here is we heat up the liquid CO2, and once it attains the critical temperature, we take advantage of the chamber pressure and temperature, and at the same time there are built-in regulators to regulate the flow. So after the cool cycle, the fill cycle will be turned on, and then once the fill takes place, then there will be a purge and fill cycle going on for about 4 to 8 minutes, and then the system will switch to heat mode. And once it heats, so right now in cool cycle we can notice the temperature is coming down, and once it comes to 5 degrees Celsius, plus minus 5 degrees, or 0 degrees Celsius plus minus 5 degrees reading is attained, the fill cycle will be initialized. And then, so when after the heating cycle is up, and if the chamber slowly heats up all the way up to 40 degrees, and that's when the supercritical CO2 phase takes place, and then the bleed valve will be turned on, and a regulator, we can also use a regulator to change the flow, and a flow meter can be used on the bleed outlet as well to monitor the flow rate. And the user's manual recommended values are available, and appropriate flow meter should be used here. So I'm going to demonstrate the system through one cycle and how it proceeds. And it will indicate how the chamber pressure will increase slowly, and then followed by the fill-up process. The pressure will go up to 700 degree psi, and also then it kicks in to the heat mode. So in order to speed up the process, I can manually turn on the fill cycle if necessary. So I've initialized the fill cycle. So we can see the fill up in progress. The chamber is getting filled up, and we can see the pressure reading going higher here. So once the chamber pressure reaches 725 psi pressure, the system will enter into auto cycle. So the filling cycle has ended, and it has switched to purge mode. Now what is going to happen is, when the purge valve is open slightly, now it is going to do fill up and purge simultaneously. So right now, the chamber is being purged. So in order to speed up the process, I reduced from 10 minutes to 5 minutes of duration. Of fill and purge lights are on, indicating both the valves are on, and all the gases purged will be entering the condenser. So when the fill and purge lights are off, the heater light will turn on and the heating cycle begins. It's always important to make sure that the lines are not bent in the L shape. Always there should be a curved bend so that the flow is adequate. While the fill and purge cycle is on, you can notice the temperature of the chamber slowly rising up. And now the heating cycle began. So in this cycle, what is to be observed is the temperature will increase slowly, and also the pressure will also increase till when the chamber pressure reaches beyond 1072 psi, it will stabilize in a range of about 1350 psi, which is plus or minus 5 to 6%. And the temperature, once it achieves 31 degrees Celsius, and the chamber temperature can be read up to going up to 40 degrees Celsius, and the critical point is passed at that point. So the critical point being 31 degrees Celsius, so the Tousimis equilibrium cycle starts, and the heated LED will begin to ping. So when it is blinking, when the heater LED is blinking, so the actual critical point cycle is on. So at the end of this equilibrium cycle, the system will enter the bleed cycle, where the bleed LED will be indicated, and after that the vent will turn on and the vent LED will be indicated. So the chambers should be open only when the pressure gauge indicates 0 psi, and this heating process is not going above 40-45 degrees Celsius. It's not very hot, but the care should be taken not to attempt to open the lid when the pressure is few hundreds of pounds per square inch. Now that is for the safety of the operator. So at this moment, the pressure is about 750 psi, and the temperature is about 18 degrees Celsius. So a typical chart would be in steps of 2 degrees of temperature. Every 2 degrees there will be an increase of 50 to 60 psi in pressure. Right now it is almost 20 degrees Celsius, and the pressure is about 800 psi. So in case of any leaks, either the chamber gasket or any of the fittings, we can hear some gas leak hissing sounds, but right now everything is tight. So frequently the gaskets should be checked, the chamber gaskets, for any particulate matter deposition, and then always use powder-free cloth and wear gloves to clean the surfaces. So in order to save the CO2, I can close the valve on my cylinder, because at the end of fill cycle there's no more fill and purge cycle, there's no more CO2 entering the chamber. So right now it is 22 degrees and the pressure is about 850 psi. So for any spare parts or accessories, please contact Tousimis customer support. They have a nice website and they do supply parts for these machines. So right now the temperature is approaching 24 degrees Celsius and the pressure is almost 900 psi. It's very important for the exhaust lines to be connected to a vent so that the exhaust gases are vented out of the room. Remember, we're talking about carbon dioxide. So in closed rooms, the accumulation of CO2 could be potentially dangerous. So as the temperature is approaching 26, I notice the pressure reading going up to 950 psi. Right now the temperature is about 28 degrees Celsius and the pressure is almost 1000 psi. Now the system is almost approaching the critical point, which is 31 degrees Celsius, at which the chamber pressure will be of the order of 1100 psi. Right now it is almost 31 degrees Celsius and the chamber pressure is close to 1070 psi, and that's the critical point we are approaching, and we can see the pressure still increasing with time. So the temperature reading is now past 32 degrees Celsius and the pressure is past 1150 psi. So the system temperature increase will continue for some more time, and at the end of this cycle the heat LED will turn off and the bleed LED will turn on. Right now the process is complete and the pressure gauge indicates 0 degrees psi, whereas the chamber is slightly warm because it is at about 39 degrees Celsius. So I'm going to slowly crack open all the locking nuts, and at no point of time you should try to miss a nut, because now that's the end of the process, and we're going to open the chamber. So that's a dry sample right there, no liquid. I'm just going to close this chamber after removing the sample.